Platinum. Have you ever found some? You know, I wanted to show you this amazing platinum nugget that I found. It's big, it's like 4 or 5 ounces. It's worth thousands of dollars. Not. This is a piece of melted aluminum that I found. And, you know, I get a lot of people who find something and they think it might be platinum, and, you know, sometimes it is. But far more common than real platinum nuggets are bits of lead, melted aluminum, other things that might kind of look like platinum. Now, what is platinum? And of course the platinum group metals. The platinum group metals are platinum, osmium, iridium, ruthenium, rhodium, and palladium. And they all have their special uses. Platinum has a lot of, and palladium too, have a lot of uses in the catalyst category. They help make reactions that might otherwise happen slowly, happen really fast. And so in the automobile catalyst category, you know, your gasoline powered automobile, if you have one, it's got a catalyst in there if it's not really old, and the catalyst will have either platinum or palladium in it. Now it's kind of interesting, when they first came out with platinum catalysts many decades ago, almost all the manufacturers, virtually all of them, used platinum as their catalyst. And what it does is it takes carbon monoxide and converts it to carbon dioxide, okay? And carbon monoxide is a poisonous gas if you breathe it, whereas carbon dioxide, yeah, you know, there's issues with global warming, but it's not a poisonous thing to breathe it. In fact, you breathe out carbon dioxide. So they all went to platinum, and after a while, when everybody was using platinum catalysts, the price of platinum went way up, and for a while, platinum was even much more expensive than gold. And so some of the manufacturers thought, well, you know, we could use palladium and it'd be a lot cheaper. Let's do that. It still works just as good. And so they all switched to palladium because platinum was so expensive. Well, then the same thing happened in reverse. The price of palladium went so high that it was way more than platinum. And now finally some of them have switched back, and you have a kind of more even thing. And platinum and palladium are at least comparable in price. They're not one wildly different than the other. But they help accelerate reactions, and of course they use them in automobiles, but they also use them in chemical processes and stuff, where you convert different kinds of chemicals to different kinds. And in fact, in manufacture of gasoline, the oil that comes out of the ground isn't usually really good for gasoline, so they have to do a process they call cracking, and they break the long molecules of oil into shorter molecules that are be able to be used as gasoline. But what about platinum nuggets? I mean, I get a lot of people asking me about stuff, you know, that they found. Hey, I think I might have found platinum. And like I say, it's entirely possible that you have. But I will admit that lead and aluminum and other stuff are a lot more common. And of course, lead can melt, and aluminum, you know, if the aluminum is shaped like a soda or a beer can, you're not going to mistake it for platinum. But if it goes into a fire and melts, it can get blobby for a melted piece, just like my melted aluminum nugget here. And it does kind of look like platinum or a platinum nugget. And so people kind of mistake that. And, you know, I'm going to tell you a little bit about platinum nuggets, what they look like, and how to test them. So let's dive in and take a look at some real nuggets, some not real nuggets, you know, I mean, stuff that isn't really platinum, but it's real, it's metal, but it's not platinum. And then talk a little bit about testing for platinum and how to recognize what it really is when you really do have the real thing. Here is a real platinum nugget. It shows the silvery gray color that platinum and platinum group nuggets, because platinum, it is rarely pure. It usually has some palladium and perhaps some osmium and iridium. And there are nuggets that are richer in osmium and iridium than in platinum. But they all have a similar appearance. The platinum group metals are all pretty much the same color. Here's another little bit larger platinum nugget, and it shows a blackish substance on the surface of the nugget. This one hasn't been rolled around in the stream as much. It's a kind of its blobby shape that it came out of the rock. But the black stuff on the surface is characteristic of a lot of platinum nuggets. Not every platinum nugget has this, but a number of them do. The black stuff is chromite, and it turns out that chromite, which is the important ore of chromium, is closely associated with platinum, although it doesn't go the other way. There's plenty of cases where there's good chrome, but not really any platinum. But where you find platinum, you almost always find some chromite. Platinum is also found in crystals, as these little platinum crystals show. They're very uncommon. I've only seen a few examples of this, but they do exist. Here's a group of platinum nuggets that came from Russia. You can see the steel silver gray that I had mentioned that is the color of these things. But unlike aluminum or steel or a lot of other metals, these nuggets are super dense. If you were to test them for density, you'd find that they're slightly more dense than a gold nugget of the same size, and a lot more dense than steel or super more dense than aluminum. So these are real platinum nuggets. This, on the other hand, is a fired bullet that's been smashed against a rock or something. And I find things like this with my metal detector all the time. Yes, it's silver gray colored, but this is lead and certainly not platinum. And this is a really nice platinum nugget from Northern California. Nice half-ounce nugget with the beautiful steel gray. And this is the real thing. When I'm out prospecting, it's not unusual for me to find bits and blobs and pieces of melted metal. Never are they as artistic as this seems to be, but this gives you the idea. Molten metal is not that unusual, and no, this is not platinum. This is another real platinum nugget. It is small and silvery, but it's super dense. This nugget, although not very large, weighs over 9 ounces. That's just because platinum is so dense. Now, this is the real thing. So this is the big phony platinum nugget I used at the beginning of this video. That's really a piece of melted aluminum. You can kind of see that there's signs of melting on it, but it's rounded and kind of looks nuggety a little bit. Still, it's a melted aluminum and a lot more common than real platinum. This thing weighs probably less than 10 ounces of aluminum. If it were platinum, it would be over 50 ounces of platinum, and like I say, probably worth $100,000 or more. This, on the other hand, is a real platinum nugget. The real key for determining real platinum is not something that can be seen in a photograph. It's the density of it, and we'll talk a little bit more about that right now. Now, the density of platinum is really high, and even though it varies somewhat because it can be mixed with other platinum group elements, palladium is a little bit less dense, and osmium and iridium are actually slightly higher than platinum. But if you measure the density of your suspected platinum nugget and it comes in at 15 or higher, then it's pretty much for sure going to be a platinum nugget, the real thing. If you measure it and it comes in at somewhere around 11, 12, 10, 11, 12, it's probably lead. Or it could be potentially, if it's 7, 8, 9, 10, it could be stainless steel. And if it comes in at like 2 or 3, I'm sorry, but the density of 2 or 3 is going to tell you that it's aluminum. Now, this is a really large real platinum nugget, and another test for platinum is to put it in acid. And the best acid to put it in for the testing would be nitric acid. You could dilute it 1 to 1.
Nitric acid is harder to come by. Another acid that can be used is hydrochloric, and you can get hydrochloric acid at Home Depot and Lowe's and that sort of thing. It's not terribly expensive, and it's not nearly as dangerous as nitric. If you put a suspected piece of aluminum into, and you dilute it 1 to 1, the same as the nitric with using the hydrochloric. If you put it in there in a 1 to 1 mix, the aluminum will start to bubble slowly at first and then accelerating. And if you have a big piece of melted aluminum, you may need to take it out because eventually the reaction will start heating up the acid, and it may be emitting so much bubbling that it looks like it's boiling. Lead, on the other hand, if you put that into hydrochloric, it will very slowly decompose and fall apart. And if you have a real platinum nugget and you put it into hydrochloric, it won't do anything. It'll just sit there. If you put a stainless steel piece into hydrochloric, it will slowly dissolve and strongly color the water because the iron in the stainless steel will color the water. So those are a couple of really good tests. Here's another real platinum nugget. I do get people tell me sometimes that they did this test where they put their suspected nugget into hydrogen peroxide and it bubbled. The problem is that there are lots of things that will make hydrogen peroxide bubble, and you could get it off of aluminum or off of stainless steel or some other thing like that, and even some lead oxides and things will do it. So that's not a valid test. It's too easy to fake with something else, and it doesn't, allow for a full determination that what you have is really platinum. The better tests are the density tests that I talk about and the dip-in acid test. Those will really tell you that what you have for sure is platinum.
Now, as I've said, real platinum nuggets are kind of rare, right? And, they're not just found, as commonly as gold. In fact, to tell you the truth, for every gold nugget that's out there, there's probably, for every 10,000 gold nuggets, there's one platinum nugget. It's that rare. Now, in the Earth's crust, actually gold and platinum have about the same concentration in regular rocks. They're tiny traces, but there's tiny traces of platinum in a lot of rocks. There's tiny traces of gold in a lot of rocks. And but why is gold deposits so much more common? Well, it's because of the chemistry of gold. The chemistry of gold and the chemistry of platinum are wildly different. And the chemistry of gold and the chemistry of platinum are wildly different. And so let's take a look at where platinum nuggets are found. Now, like I say, this is not an exhaustive study, but it'll give you some good ideas about places where platinum is found and where you might look to find platinum.
Okay, so let's dive in and talk about world platinum deposits. Now, there's a whole lot of dots on this map all over in all the continents, but this is not 100% efficient map, and it doesn't show every place. Even in the United States, I've seen platinum nuggets from Arizona, and there's no Arizona marked on here. And Nevada has some of the right geology, but I've never seen platinum from Nevada. So, I've never seen placer platinum from Nevada. There are some ores that contain platinum in Nevada. But anyway, this gives us an idea, and we're going to start by dividing it into Eastern and Western hemispheres so we can talk in more detail. So let's dive in with the Western hemisphere. Okay, well, you can see that there's a number of places in both the U.S., Canada, and, of course, South America. Of all the spots on here that have the countries that have produced the most placer platinum, Colombia is going to be the winner. Colombia has produced a huge amount, and, in fact, the Spaniards in the early days found this silvery stuff, and, they determined quickly it wasn't silver, but they didn't know what it was, and it was platinum. And so a lot of platinum has come from South America, no doubt. But then quite a bit has come from North America, too. In the United States, probably the biggest producer has been Alaska, with California probably running a close second behind. Alaska has had a placer dredging operation, at least it did, for many decades. And while there have been a number of places in Alaska that have produced some platinum, the big producer for Alaska has been Good News Bay on the southwestern corner there on a peninsula. And there's been a dredge there that ran for years. And this is the actual dredge operating there at Good News Bay. Now, I think they got some gold along with the platinum, but the principal product that they were going off, the principal product was platinum, and gold was just a byproduct. And the most of the money that they made was off of platinum. And they got some decent-sized nuggets. A lot of it was fines. The platinum placer was fines. But they got some decent platinum nuggets there as well. And here are a few of those nuggets. These three are between 1/4 and 1/2 ounce in size. They got a few bigger, but these are nice chunky nuggets, and these all came from Good News Bay in Alaska. Next in importance is California, and platinum has been found in a number of areas, widespread in small amounts across a lot of California, both in the northern part of the Mother Lode and in the far north in northwest California. It was mined both as a byproduct from bucket line dredging, as shown in this picture, and also as a byproduct of hydraulic mining, as shown in this picture, and especially in Trinity County and Klamath counties, and this is marked Trinity, but they did this kind of mining in Trinity and Klamath, and both of them produced significant byproduct platinum. And this is a 1/2 ounce nugget, and look, it's not very big, but platinum is very dense and heavy, and this is a 1/2 ounce nugget from Trinity County, likely taken by hydraulic mining. In California and in many other places, platinum nuggets are closely associated with outcrops of serpentine rock, or serpentinite if you're up to the latest call of it. And they're marked in green on this map. And now, I won't say that every place marked in green that has this rock outcropping is going to have platinum nuggets. That's definitely not true. But all the places where there are platinum are associated with this. And you can see that along the foothills of the Sierra, the western foothills, and even across away in the coast ranges, and of course farther northwest in the Klamath and Trinity area, there's a lot of this kind of rock outcropping, and there was a lot of platinum found up there. Here's an example of that rock, serpentine, and like I say, it's waxy and kind of dark colored. It can be greenish like this to more gray. Here's a more grayish green example, a picture that I took in a road cut in California. Now, will there be platinum deposits and nuggets associated with every outcropping of this kind of rock? No, of course not. Definitely not. The rock is a lot more common than platinum nuggets. And some outcrops of this kind of rock will have platinum, but most will not. But still, wherever you find this, there's at least good potential to find platinum. Now, the outcrops of this serpentine or serpentinite rock continue north from California, up through Oregon, through Washington, even into British Columbia, Yukon, and even into Alaska. You know, the Good News Bay placers that we looked at earlier, those are associated with the serpentinite types of outcrops, and they're of the same general geology that produces the nuggets in California and Washington and elsewhere. Here's a handful of nuggets from the state of Washington from this similar geology where the platinum is associated with the serpentinite rock. And so it's wherever you find this, there's at least potential. There's no guarantees, but there's at least potential. And I think that the same thing holds true for some of the areas where it's not so well recorded, you know, in Arizona and other places where some platinum has been found, and some places in California where it's not well known for platinum, but some nuggets have been found. It's always associated with this serpentinite rock that I showed you.
Now, as I've kind of mentioned, the geology of platinum and the geology of gold are wildly, wildly different. And the fact of the matter is that gold, when it's exposed to hot, sulfury waters, can actually be dissolved into the hot, sulfury waters. And that's how gold, almost all gold deposits form originally. The hot, sulfury waters will dissolve the tiny traces of gold out of various kinds of rocks that have tiny traces of gold in them and bring them together to a point where they can be reconcentrated. Whether it's a gold vein, a gold quartz vein, or whether it's some other kind of deposit, the tiny traces of gold are leached out and concentrated in a certain area. Platinum is really different. It's not so soluble in hot, sulfury waters. So, the same kind of thing that makes a gold deposit doesn't make a platinum deposit. And that's why once in a while when I get people tell me, hey, I got this great assay, it's high in gold and high in platinum. I've got, my ore is worth $10 jillion because it's super rich in gold and super rich in platinum. And you just say to those people, it's like, probably about a 98% chance that your assay is bogus. That you paid somebody to give you an assay and they gave you a bogus assay. It's funny that bogus assayers don't know enough chemistry to know that platinum and gold very, very rarely occur together in significant quantities. Traces of gold, traces of platinum? Well, yeah, lots of rocks have traces of gold and traces of platinum. And some ore deposits have traces of both. But, there's not deposits where there's lots of gold and lots of platinum. That just is like something that doesn't happen. But you bogus assayers will give that result because it's what people want to hear, right? So let's talk about the geology of platinum hard rock deposits. The unusual way, because usually platinum hard rock deposits form from molten rocks concentrating the platinum. And that's why it takes just the right conditions and the right kind of molten rocks to slowly cool and allow the platinum to come together and form a platinum deposit. So let's talk about that, how platinum hard rock deposits form.
Worldwide, platinum group element together with nickel and chromium mineralization is primarily of magmatic origin, meaning that it comes from the melting and partial congealing and separation of the melted rock. The platinum group elements, together with nickel and chromite, they coexist in nature and are hosted primarily in basically iron-rich rocks, iron-rich and silica-poor rocks that come from deep in the earth, and usually from a partial melting of the mantle or an upwelling, a mantle plume. Geologically, the vast majority of known platinum group element resources are contained in magmatic sulfide-type deposits, where the sulfur and the platinum and together with nickel and copper and sometimes cobalt come together and they segregate from the melt, and you can have repeated injections of basalt and the sulfur and the metals settle out toward the bottom, eventually forming layers or reefs that are rich, and basically they're stratabound or layer type platinum enriched lode mineralizations in mafic to ultramafic types of rocks. Now the Alaskan type platinum group element rich placer deposits, this is what's formed in Alaska as well as California and up and down the west coast, are thought to form from chromite-rich dunite units, meaning dunite and peridotite are very iron-rich rocks that come from deep within the earth, and they come up, and when they're altered near the surface, they form the serpentine that I had showed you earlier. This diagram kind of shows the nature of these three rocks, or these three types of deposits. On the right is what they call ophiolite-hosted deposits. These are the serpentine-related type that form placer platinum, and they're basically upwelling of rocks that you see on the right there. There's like a plate tectonic, and one plate is being subducted underneath. The ocean plate is going underneath the continental plate, and molten blobs come up from the melting of the plate when it gets to the mantle, and it's those types of ascending molten lava that's really rich in iron that forms the serpentine and gives us the placer type platinum. The middle one is, again, a molten rock segregation, chromatolite hosted nickel copper. It can have significant platinum in it. And then the one on the left is the layered intrusion, where it cools very slowly and forms layers of sulfides. This is like the Stillwater complex deposit in Montana and other deposits around the world, especially like the Bushveld igneous intrusion complex in South Africa. It contains the largest and richest chromite and platinum group element deposits in the world. It's characterized by these layered ultramafic intrusions with stratiform deposits of sulfide, chromite, and magnetite.
Now let's talk about recognizing platinum or platinum group element ores, ores and deposits, and where they are and what the ores look like, because it's really interesting that ores, like I say, they're very different. They're not quartz veins like you're used to with gold. It's very different kinds of rocks, almost always very dark colored rocks, because they're rocks rich in iron, rocks that came from deep within the earth. So platinum has its own unique geology. All the platinum group elements have their own unique geology. And so let's dive in and talk about recognizing platinum group element ores.
This photo shows some platinum ore from a rather large mine in the Stillwater complex of Montana. It's dark colored and is a volcanic material, a magma that cooled very slowly. And it's a lot of feldspar and other things, but you can see the light colored clots that I'm pointing to here. Those are clots of sulfides, and in these sulfides is mixed in some minerals which contain, like chalcopyrite and other things, which do contain some both platinum group metals, mostly palladium, but also some platinum as well. Here is another example of platinum ore from that same mine, and again it's clots and bits of sulfides in this ore. The ore is crushed and the sulfides separated out away from the gangue and waste minerals. One of the things I want to say about ores like this is that there are probably 10,000 gold mines for every one platinum palladium mine that exists in the United States. That's how rare these mines are. They just are crazy rare. Now, at this particular mine, the zone, basically it's almost like a vein or layer that these people are mining, goes on for tens of miles. So it is very extensive in size, but they are very, very, very rare.
Here's where that deposit is in way south central Montana, and it's an area with rocks that came up from deep within the earth. There's a chromium mine that operated here back in the 30s. And so, this is another element that comes up from deep in the earth. And the truth is, the reason I mentioned why there's 10,000 gold mines for every platinum mine is because the chemistry of gold is so much easier to work with. It produces natural concentrations. Just, that's how it works because of the chemistry. But the chemistry of platinum just doesn't work that way. It just doesn't reform like that. It's just more difficult. So there just results in fewer natural concentrations. Another location where there is copper, nickel, platinum type deposits with a similar geology in the United States is the Duluth complex up in Minnesota, not so far from Duluth. This is a complex of gabbroic rocks, most of which is on the north side of Lake Superior, a little bit on the south side of Lake Superior. These have been explored for years and may potentially be productive, but have not been much productive yet. Here's a close-up of that complex, and you can see along the far north edge of it, of the gabbro rocks, is these basic areas where copper and nickel sulfides have segregated out, and then there's platinum group elements with it, and it's rich in iron and titanium as well. But like I say, this is a potential for the future. It has not been as productive, certainly not as much as the Stillwater complex in Montana, which has been in production for many decades. Here's a close-up of the segregations, the clots of sulfides that are found in these rocks. And the more silvery colored sulfides, that's a sulfide, an iron sulfide called pyrrhotite. And then the more yellow brassy ones is the chalcopyrite. And in the chalcopyrite, of course, there's plenty of copper. It's a copper sulfide mineral. And in the pyrrhotite is the nickel and platinum and that kind of thing. So there's small amounts of nickel and platinum in this, and that's what they recover from these ores along with the copper.
This is a very unusual ore specimen from Nevada. It contains a whole lot of base metals, but a small amount of platinum. And this mine did produce a tiny amount of platinum, but it's not like the big producers. And again, it's super rare.
Here's a diagram of the world's most important hard rock platinum deposits. Now you'll notice this is very different from what I've shown as far as placer deposits. These are hard rock, and generally speaking, these types of hard rock deposits don't throw placers, and the types of geology that throws the placers, it doesn't produce hard rock types of deposits. It's a different geology. But you can see the United States and especially Canada are well endowed with good deposits, as well as Australia and Russia as well, and South Africa. And this map just sums up the countries that are the biggest producers. And that's, of course, Canada and the United States, Russia and South Africa. That's the biggest hard rock producers for platinum. So to look at this, we should talk about platinum containing minerals. I mean, so far what I've shown you is other base metal sulfides, iron and copper rich and nickel rich, that contain small amounts of platinum in the sulfide minerals, but they're not really, having significant amounts of platinum in the sulfides. It's mostly small amounts that they're able to extract in smelting. But there is one mineral, and this is it, sperrylite. The silver mineral you see here is rich in platinum and is an important ore mineral in some types of hard rock platinum deposits.
The silver-colored triangular-shaped mineral in the center of this photo is a mineral called sperrylite, and it's the only known mineral that actually contains significant quantities of platinum in its chemical formula. It's a platinum arsenide mineral. It's very rare, super rare, and there's a zillion silver-colored minerals. So just because you found a silver-colored mineral, that doesn't mean you found platinum. But anyway, it is an important ore of platinum.
Now, whatever you're prospecting for, whatever you're out looking for, whether it be gold, platinum, gold and platinum, because gold and platinum, like I say, do occur in placer deposits. The geology of the deposit that originally formed is wildly different, but erosion of a gold deposit and erosion of a platinum deposit can bring the gravels together, and form gravels that have both of those together because they're very different deposits, but they've been eroded and put together. Now, whatever you're doing, however you're prospecting, what you know makes a huge difference in how successful you are. And in order to impart to you those skills of learning to do that, and how to find gold, and my book, even though it's mostly about gold, has a whole big section in the back about platinum too. And so what you know makes all the difference. And I wrote a book called Fistful of Gold. And then I also have a partnership with an outfit called High Plains Prospectors. And I'm going to give you a link to that and tell you a little bit more about High Plains Prospectors and about my book Fistful of Gold right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's Like I say, an encyclopedia, there's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.